802.11, 802.11a, b, g, and so on. Okay, so these are today's technologies where you can get as much as 54 megabits per second and even higher. So that's pretty good. Your Ethernet until recently was 10 megabits per second, wired Ethernet, and today it's 100 megabits per second. But so you can get pretty good rates competitive with wired networks if you just want to be within a building, basically. And as you go further and further, as you go to miles and tens of miles and so on, then there are all these cell phone oriented technologies. There's 2G and 3G for second generation, third generation, and surely there's going to be a 4G after that. And here you're really talking about 56 kilobits per second being more or less the norm today, that range, and people hoping to get to 384 kilobits per second. So if you hope to use wireless to get long distances, then you're going to get much less bandwidth. This is a small fraction of what you can get internally, and that makes sense. And there are technologies that would provide higher bandwidth at for longer distances, and these would be the more like point-to-point technologies. Okay, because in the cell phone, it's one of the reasons for lower bandwidth is that lots of people are sharing the same medium. So if you had certain conditions where there's only two people, then you can send data at a much higher rate. Okay, so you can get higher also on long distances, but you can't. Everybody can't do it at the same time. Okay, so this is a very rough idea, and some of these we will look at a little bit more detail in the course of this this chapter or this topic. Any questions here? Has anybody tried to use emails on their cell phone? No? Does it work? People get very good at sending 2-3 word messages. Suddenly you're back to where you were maybe 5-10 years ago with regular computers when you try to use a completely cell phone based internet link. Okay. More buzzwords. There's the infrastructure mode for wireless operation, and infrastructure mode basically means that the base station connects to everybody. So every user connects to one base station, and then the base station does the rest. Okay, so generally using the wired infrastructure. Of course, base stations can change if you travel from one point to the other. Initially, you'll be connected to one base station. At some point, you'll move to another base station. But the basic point is, this is always the case when you're using a cell phone, that you don't ever directly talk to another cell phone user directly. You might have two cell phones right next to each other. When you make a phone call, it's going to the base station, going back to the infrastructure, and then maybe coming back to you. So it's always through the infrastructure that you talk to each other. Okay. There is the ad hoc mode, and where there's no base stations and nodes only talk to each other. And basically, this is generally used if there is a meeting where everybody needs to exchange notes. Okay, so you have 10 users or 4 users, and you set up your laptops typically, and you start working, and there's an underlying protocol which connects to all of you. Okay, so you can communicate with each other, but there's no infrastructure here. This is not connected to the rest of the world. So the keys and nodes themselves organize into a network, and it's interesting to see here that these protocols do take into account that this is the range of this particular node. You have limited range in wireless, and this is the range of this node. So, but these two nodes can still talk to each other it is going to use the in-between nodes as routers in this case to forward the packets. Okay. Of course, this guy cannot talk to anybody because there isn't a single other node that is in its direct wireless range. So that's the task of the ad hoc routing protocols, to make sure that everybody can talk to everybody without unnecessary, without excessive retransmission, and to change dynamically as these users move around, because in a few minutes this guy might move and then his range is here and suddenly is connected now to the, well actually here, and it's connected to the others, and then the routing protocol has to take care of it. Okay. Okay, so basically the infrastructure mode and the ad hoc mode. So those are the things. So moving on, the first thing is that do we even need to treat wireless differently? As in terms of the link layer technology, we had enough problems with wired Ethernet. So can't we just use the same thing, wired Ethernet, you sent a message when nobody else was sending, and then if there was a collision, you retransmit it and everything. So who cares whether it's wired or wireless? Could you use the same ideas to communicate? And so here is some of the things that are unique about wireless, which force you to change some of those ideas, or although many of those same ideas apply across wired and wireless. So what is the one thing is decreased signal strength. In the wired world, if you're connected by two wires with the appropriate technology, you're either connected or you're not. You're not slightly connected, you're not half connected, or your bandwidth doesn't keep wearing. You're generally fully connected. So here, when you have many nodes, your signal strength keeps decreasing. So you have a bunch of nodes in an area, and each can communicate with the other at different capacities because of the strength of the signal. It depends on distance, and it depends on what lies in between the two nodes. So yeah, so the second point is the interference. You have to deal with the fact that the frequencies that you use, let's say 2.4 gigahertz is a popular frequency, they may be used by other people and other things, right? So when you are in a wired world, you assume that your Ethernet cable is also not also going to carry electricity or telephone signals and so on, right? It's dedicated to you. But you can never be sure in wireless. It might be a motor that's transmitting at the same frequency. It could be a cell phone. It could be a microwave. There's a lot of things that can interfere. So there's more uncertainty. And another annoying thing is that radio signal reflects off objects. So what that means is that you may get two signals, one at one time and second reflected one a few seconds later, or more like a few nanoseconds or microseconds later, but enough to be a factor to be, yeah, so the basic idea is that wireless is more difficult than wired. A lot of things you took for granted in wireless, you cannot assume I'm sorry, switching everything. A lot of things you took for granted in wired, you cannot do that for wireless, so you have to worry about more things. Okay. Let's see. So one specific example here is again, it comes down to why can't I just use wired Ethernet ideas in wireless? And one thing is that it's entirely possible that A, B, and C are nodes in a network, and A can talk to B, and B can talk to C, but A cannot talk to C. Okay? Can be two reasons. One is that A and C are just too far away, so they cannot talk to each other simply because of the distance. And the second is just like there's an object between A and C. They may be physically close by, but they cannot hear each other because there's a big mountain of books in between which doesn't let the radio signal through or something. Okay? So this is the two reasons why you can have a group of nodes where only some can talk to the other. One is the signal fading, and the other is the so-called hidden terminal problem. Okay? And that causes a lot of issues because when we were thinking of wired networks, we just assumed we broadcast